Hello my dear students, and welcome once again to another video for our class in object-oriented programming. In this video, we are going to talk about the concept of inheritance in OOP, and later on we'll have some coding demonstration using the Java programming language. Let's get to it. So what is inheritance? Inheritance is one of the pillars of object-oriented programming. It is a powerful feature that is present in all object-oriented programming languages. That is a key element in making software development faster, more reliable, and more robust. With inheritance, an object can inherit from another object. The things that an object can inherit are the properties, that is, the data of the object, and behaviors, or the things that an object can perform as it is defined in the code. There are two players in the concept of inheritance. The superclass, firstly, it is also known as the parent class, the class which serves as the source of the inheritance. And the other one is the subclass. It is also known as the child class, which is the recipient of the inheritance. So why do we need to have or use inheritance? Because we don't have to rewrite the same code across the different classes that share the same set of data and behavior. Inheritance greatly promotes code reusability. And in many cases, in the real-life world of software development, a lot of them require hierarchical structuring or relationship, which the concept of inheritance also provides. Finally, the power of polymorphism is a really powerful feature in OOP as well, which is part of the fruit of having the inheritance feature. We will talk about more about polymorphism in a later session. Let's take a look at a simple illustration of how objects and classes relate with each other in the concept of inheritance. Say, for example, we have a class person, and based on our definition of the class person, it has three data. Three properties, which is the name of the person, the birth date of the person, and the address of the person. And we also have here three behaviors of the class person, which means that a person can talk, a person can sleep, and a person can work. With the power of inheritance, we can create another class that is going to inherit from the class person. Say, for example, a more specific type of person can be an employee. You see, every employee is a person. So, it is thus fitting for an employee to also have a name, a birth date, and an address, or whatever a person can do. But besides the data that it inherits from the person, employee will now have a more specific set of data and as well a more specific set of behavior. So besides an employee having name, birth date, and address that is inherited from the class person, the class employee will also have employee number, position, salary rate. As well, it will also have additional behavior. In this example, an employee can do time out, time in, and also can make a leave. Another example would be a class student is also a person, and therefore a student may have name, birth date, and address. But besides that, you can now add more data, more specific data to the class student, which is the student number, in this case, course, and year, as well as more specific behavior, which is to enroll, withdraw, etc. As you can see, in the inheritance hierarchy, the parent class is a more general class, and the child class is the more specific class. Let's do some coding demonstration. And just one hint of advice that in programming, you have to do a lot of practice, iteration, repetition to somehow understand the concepts more deeper. So at this point, let us now do coding demonstration. Alright, so here we are once again in our Visual Studio Code editor, and the first thing I want to do is to create a new file and call this file person.java, and we'll define the class person. First we'll have the name, the address, and birth date. And by the way, date should be imported, I guess. Can have the util date, and let's put some of the methods, the methods that this person can do. It can talk, so I'll have public. Let's first have the constructor and the accessors and mutators. You can do this by doing source action and generate constructors. We'll select all of our properties and click on OK, and it will write this constructor here. And we'll probably also need to have an overloaded constructor just in case we want to instantiate a person without any parameters. And we'll just call this name equals let's just say unknown, and address is nowhere, and the birth date, we'll just set it to null. Alright, so now we can do instantiation of a person with parameters and instantiation of a person without parameters, and we'll just have some default values for it. Also, let us not forget to add as well our getters and setters. So again, check everything here, click on OK, and we have the standard getters and setters. We already taken this, talked about this in the earlier sessions. So if you have forgotten about the setters and getters or accessors and mutators, do check out that video. So now we can add our behavior for this person class, and yeah, the first one was it can talk. And what should it talk? What should it say? Maybe we'll just display a message of this particular person telling about himself. So let's just have hello, my name is, and then we pass in the name, which is that, and I live in, and then we pass in the address. All right, so that's talk. And what was the other one? Sleep. All right, so let's do void sleep, and so we'll just display a message that says name is sleeping, and the other one is work. So let me just copy this code real quick, and I'll just rename this to work, and this is working. All right, that's how we have defined our class person. Now let's create another class, employee, that is going to inherit from the class person. So let's create a new file. We call this employee.java. And again, same thing here, but the additional piece of code that will tell that this particular class wanted to inherit from another class is through the use of the extends keyword. And then after the extends keyword, you write in the name of the class. In this case, person. One thing to note is that in this particular example, we're not using any packaging. So by default, the basis for your classes to be able to communicate with another classes if they are in the same directory. So in this case, we have person.java and employee.java. They are both in the same directory called week 5. So employee class can actually access or can actually see a person class. So with this keyword, the person class is inherited by the employee class. And in fact, from here, if we are not going to do anything, that would be fine. Employee would be a complete class because employee will now have 3 properties, which is name, birth date, and address, right? Because it inherited from class person. To demonstrate this, let's just create a new class here for demo.java. And inside of demo.java, we're going to create a main method. And from main method, we are going to instantiate an employee. So we have here employee E1 is equal to new employee. All right. And from here, we can actually use employee directly. Say, for example, if we wanted to display the name of the employee, we could say E1. Let's display it using a standard output. And you say E1 dot get name using the getter right there. And if you run this program, it is going to display unknown. See that? Unknown. That is because we instantiated the new employee without parameter. Okay? And which is the same as instantiating a person without parameter, and it sets the name to unknown, address to nowhere, and birthday to null. Alright? But if we are going to instantiate this with parameters, we cannot do it at right now because we don't have a definition of a constructor in the class employee with parameters. But we can do instantiation of the class employee without parameters because this is the default constructor that we are calling. Although we don't have a constructor here, there is a default constructor that is part of every class when you create a new class, which is then being overridden when we define an actual constructor in our code. There's a special keyword that is used in inheritance, which is the super keyword, which pertains to or refers to the superclass of a child class or the superclass of a subclass. In this case, employee is a subclass and person is the superclass. So the keyword super is going to reference the class person. We'll use this super keyword in our constructor. For example, if we wanted to have or to be able to instantiate our employee with parameters, we can do that. So we'll make use of the super keyword by creating here a new constructor and providing some parameters. Okay. In this example, we really need to use the super keyword because these variables, these parameters have to be stored into uh, the properties of the class person. And to do that, we can just call the super keyword as a constructor. So the super with a parenthesis is simply a reference to the constructor of the superclass. And since our superclass in this case is the class person, and our class person has a constructor that has a string, and a date as a signature, we are going to call that here. We are having a name, which is a string, the address, which is another string, and birth date, which is also a date. So effectively, we are trying to create here a constructor for the class employee, which we can provide parameters for the inherited properties. And to implement that, we just call the super, which is a call to the superclass's constructor, and thus will be able to execute and store the values in the parameters into their proper properties. So now, if we come back here, you'll notice that it's already an error because we no longer have a constructor without a parameter in the employee class. Because like I said, when you add a new constructor in your code, it overrides the default constructor. And so this was the default constructor and it was overridden. That is why it's no longer there. Anyway, we can have here instead a constructor with parameters. Remember, the signature of the parameter is a string for the name, followed by a string for the address, followed by a date for the birth date. So let me just first define a date here for my B date. And right there. I'll put here my birth date, 79 10/02 T. I don't know what time it is, but let's just say 8:30. Okay, and let's import this. Okay, so we have our birth date. Now we can instantiate our employee with the name, the address, and the birth date, which is that. Okay, and now if you run this program, it's going to show the name of E1, which is now being changed to that Benjelenteria. All right. So let's now add the specific data or properties for the class employee. You can do private int employee number, private. What was the other ones? I forgot what they were. Yeah, it was string position. And we'll have also salary rate. Okay, and now we can also add setters and getters for these three. So you can just do right click, source action, and they'll go to generate getters and setters and check them all. And now we have all the getters and setters for all our properties here. And besides that, we can also now update our constructor so that it will include parameters for these additional specific properties. So simply add a comma and we can have here int. That should be employee number. You have to refactor this one first. Why can't we do refactoring here? I don't know. But there should be ye. Okay, anyway, so we have here int employee no, then the string for position, and double for salary rate. Now the super call is going to be placed here still, and one rule about a super call, it has to be the first line of code in that block, so it remains there because this is the one that is going to assign these parameters to the inherited properties. And after that, we can now set our specific properties. In this case, this that employee number is equal to employee number. This that position is equal to position, and this that salary rate is equal to salary rate. Alright, so there's our constructor now. Of course, in the demo, this is not going to work anymore because there's no longer a constructor having this signature, because our constructor for our employee now has additional parameters. So let's fix this as well in our demo, just for the sake of clarity. Let me bump down our code here. And so here we can add what's the first one? Employee number. I'm just going to say 24 is my employee number, and my position is at systems administrator, and finally my salary rate is, let's just say 20,000.00 because it's a double. And so there it's fixed. There's no longer an error. So that's it. This employee class is a subclass of person, and now because of that, E1 can do get name. Remember, employee.java do not have a method that says get name, but it is able to call it because the get name method is inherited by employee from the class person. Also, if for example we are going to call E1.talk, what will happen is, of course, it's going to display the name first, which is Benzolenteria, and then executes the talk method, which displays a message that says here, hello, my name is Benzolenteria, I live in Clarin, Bohol. So, and again, this talk method was not defined in the employee.java, but we are able to use this talk method because this was inherited by employee.java from person.java. Okay, so that is the concept of inheritance. I hope that you have learned something from this session. I think that will be it for this session. Thank you so much for watching, and see you again in the next one.